Welcome. Today we will learn about the characteristics of the roots of quadratic equation. This is the general form of the quadratic equation. X square plus bx plus c is equal to 0. What are the roots of this quadratic equation? That equation we derived last time. That is x is equal to minus b plus minus root over b square minus 4 ac divided by 2a. b is the coefficient of this term and a is the coefficient of this term. Okay, and c is this constant. So there are two roots here that we can say x1 and x2. Let x1 is one root, that is minus b plus minus root over minus b plus root over b square minus 4ac divided by 2a, and x2 is minus b. Now we'll take minus b square minus 4ac divided by 2a. So we'll take plus and we'll get one root, and we'll next time take minus, so we'll get another root. These are the two roots derived from this formula. Okay, now let us take one example, that is our favorite example. X square minus 5x plus 6 is equal to 0. We can find the equation, we can find the roots of this equation by simply factorizing this polynomial. That is, factorizing we will get x minus 2 into x minus 3, that is equal to 0. This is the factorization of this polynomial. So we get x is equal to 2 and x is equal to 3. These are the two roots of this polynomial. Okay, now let us apply this formula so that we will get two roots of this equation. Let us now use it. That is x is equal to minus b. b is what? Comparing this with this general form, we can say that a is equal to 1. The coefficient here, it is 1, and b is minus 5. b is equal to minus 5, and c is how much? c is 6. Now we will put these values in this formula, so we will get the roots. X is equal to minus b, that is minus of minus 5, that is 5, plus minus root over b square, that is minus 5 squared, it is 25, minus 4ac, 4 a is 1 and c is 6, that is minus 24, divided by 2a, a is 1, so it is 2. So we get x1 and x2, two roots, that is x1, that is 5, plus this is 25 minus 24, that is 1, root of 1 is 1, 5 plus 1 divided by 2, and so we get, that is 6 by 2, that is 3. Similarly, x2 is equal to 5. We'll take minus this 5 minus 1 divided by 2, so it will be 5 minus 1 is 4 by 2. So whether you use this factorization method or this formula, we will get the same value. This formula that we derived last time from that squaring method. So these are the roots that you can find. Suppose now I'll change this equation little bit. Suppose it will be, let it be 2. Equation is now x square minus 5x plus, let it be 2, that is equal to 0. Now can you factorize this? It is difficult to factorize, isn't it? Now let us use this formula, that x is equal to minus b plus minus root over b square minus 4ac by 2a. We'll use this formula to find the roots. Here a is what? It is 1, and b is minus 5, and c is 2. Now let us use this. So we get x is equal to minus b. It is minus of minus 5, that is 5, plus minus root over b square. Minus 5 squared, it will be 25, minus 4ac. A is 1 and c is 2, so 4ac will be 8. Okay, divided by 2a. 2a is 2, so you get x is equal to 5 plus minus root over, this is how much? This is 17 divided by 2. Now you can see that root of this is it is not an integer. Okay, so you will not get the integer solution. So you get x is equal to 5 plus root 17 divided by 2 is x1, and x2 is equal to 5 minus root over 17 by 2. These are the two roots of the equation. You can see that by using this formula we can easily find the roots, but using this factorization method, it is difficult, very difficult to factorize this. Okay, so you can see that this is very easy to apply this formula. Now let us think about this equation. You can see that this, when we will get the solution, what will happen if this b square minus 4ac is negative? Can you find the root of b square minus 4ac if it will be negative? No. Let us consider one more case. Let the equation is x square minus 5x plus this is 8 is equal to 0. Consider this equation. Now using this formula we can say that the roots are x is equal to minus b plus minus root over b square 25 minus 4ac, that is minus 32. A is 1 and c is 8, so it will be minus 32 divided by 2a. Sorry, divided by 2. A is 1. Okay, so you get the roots 5 plus minus root over 25 minus 32 is how much? It is minus 7 divided by 2. You can see that root over of minus 7, it is not possible to find the root over of minus 7. Okay, because the root over of suppose square of x is equal to 7. In that case you can find x is equal to plus 7 and plus and minus root 7. Okay, but root over of minus 7 you cannot find it, and this quantity is known as the imaginary number. Okay, and in that case you cannot find the real root of this equation. Okay, so what is the condition in which case we can find the real root? This quantity b square minus 4ac, this should be greater than 0. Okay, if it will be equal to 0, so we will get minus b plus minus 0 divided by 2a, that is minus b by 2a. Roots are x is equal to minus b plus minus root over b square minus 4ac divided by 2a. So for real roots, b square minus 4ac should be greater than or equal to 0. Okay, and when the roots will be, two roots will be different, that means for distinct roots, two roots are distinct, two roots are different. In that case b square minus 4ac, b square minus 4ac should be greater than 0. This should be greater than 0, so that the roots will be different. One will be minus b plus root of this and another will be minus b minus root of this divided by 2a. And when this will be 0, it will be the roots will be, when it will be 0, the roots will be the same. Okay, same roots, b square minus 4ac should be equal to 0. This is the condition when the roots will be the same. Okay, because this quantity will be 0 means one root will be minus b plus 0 divided by 2a, another will be minus b minus 0 divided by 2a. That means minus b by 2a. So in this case the roots will be minus b divided by 2. Both the roots will be this. And when the this is called a discriminator. Okay, discriminator. Discriminator, this b square minus 4ac, this is called the discriminator. And when this discriminator will be greater than equal to 0, the roots will be real, and when it will be greater than 0, that will be for distinct roots. The two roots will be different, and when it will be 0, this will be 0, the roots will be the same. And when this quantity will be, that means this discriminator will be less than 0, then there will be no real roots. It will be imaginary, and this root is called as complex. And we will discuss more about the complex roots later. Okay, that's all for now.